What is a Zener diode? Zener diodes are semiconductor devices that allow current to flow in both directions, but specialized in current flowing in reverse. Also known as breakdown diodes, Zener diodes are the most common electronic component used as stable voltage reference for electronic circuits. American physicist Dr. Clarence Melvin Zener first described the electronic properties of a Zener diode while researching the breakdown mechanisms of a semiconductor material. As a theoretical physicist at Bell Labs in New Jersey, he wrote a research paper later published in 1934, identifying a type of electrical breakdown later known as the Zener effect. These specific processes were named after him in the years afterwards in his honor. Zener diodes are designed to have specific breakdown voltage so that it will conduct current in reverse when the cathode reaches a threshold voltage. Breakdown voltage can be as low as 2.4 volts and as high as 1,000 volts. Some of the most common applications for Zener diodes are voltage regulation, voltage reference, surge suppressors, switching signals, and clipping waveforms, among many other applications. The cathode is typically connected to the positive voltage. The Zener diode will not conduct electricity from cathode to anode until the breakdown voltage is reached. The anode is typically connected to ground. If positive voltage is applied to the anode, it will conduct like a regular diode. Current going across the terminals in reverse bias, backwards, is called the Zener effect. When the voltage potential is met, this causes the Zener voltage or breakdown voltage. Zener diodes uniquely consist of a heavily doped P-N junction that allows current to flow in reverse when reaching the Zener voltage. As well defined, Zener voltage can conduct current continuously in reverse bias without getting damaged. Current then increases to a maximum level determined by a series resistor and stabilizes, remaining constant over a range of applied voltages. Therefore, Zener diodes are applicable for use as voltage regulators. A Zener diode operates within the normal range of forward bias. A turn-on voltage between 0.3 volts and 0.7 volts. When connected in reverse bias, the current flow backwards, thus causing a small leakage of current to flow. As the reverse voltage increases to the range Zener voltage, current flows through the diode. Current increases to a maximum decided by the series resistor and then stabilizes the constant over a range of applied voltages. Zener diodes have two breakdown effects. Knowing these two effects will help you understand the functionality First is the Zener effect, prevalent in voltages below 5.5 volts, and involves a tunneling effect to cause the breakdown. The second is the avalanche breakdown, or impact ionization, which occurs in voltages above 5.5 volts. This breakdown both results in the same behavior, and they do not require different circuitry, but each does have a different temperature coefficient. The Zener effect has an anode negative terminal temperature coefficient, while the avalanche has a cathode positive terminal temperature coefficient. Both temperatures of things are almost equal to 5.5 volts. They cancel each other out, making the Zener diodes rated at about 5.5 volts and stable over a wide range of temperature requirements. Think of a Zener diode like two diodes in parallel, facing opposite directions. The voltage that's forward biased in a Zener diode has a voltage drop of about 1 volt, needed for the diode to turn on for the current to flow. The forward voltage is forward biased. The current flowing backwards is considered the Zener voltage, or reversed biased due to its properties. An example of Zener voltage is 3.3 volts for the current to flow across the diode. The current must maintain at least a minimum of this voltage, having a predictable voltage drop that makes Zener diodes not only useful as voltage regulators, but as correctly said, Zener diodes may limit the voltage of other devices. Zener diode examples and applications. First, surge protector. An electrical device also known as a surge protector that is used to protect equipment against power surges and voltage spikes while blocking voltage over safe threshold of approximately 120 volts. Switching signals. An output signal switching device, or OSSD, is an electronic device in a machine safety system that provides a coded signal that, when interrupted due to the safety event, signals the machine to shut down. This helps avoid stray signal operating a machine during unsafe conditions. Voltage reference. An electrical device that produces a fixed or constant voltage regardless of the loading on the device. Power supply variations, temperature changes, and the passage of time. Voltage regulator. When the load voltage equals the Zener voltage of a diode, the series connector resistors limit the current through the diode. This serves to regulate voltage when there is an excess amount of voltage while the diode is conducting. The diode generates noise. This can be suppressed by adding a large value decoupling capacitor across the diode. Voltage shifter. When applied to the circuit with a resistor, Zener diodes act like a voltage shifter. The circuit lowers the output voltage equal to the diode's Zener voltage. Waveform clippers. This device reshapes a signal and prevents voltage spikes from affecting the circuits connected to a power supply. Again, thank you guys for watching. And if you like my videos, please like, share, and subscribe.